16.1, task 2. So in this task, we are asked, can the order of the terms be changed if you are subtracting? Can I switch that order? Meaning, okay, so if I had 4x minus 5x, could I change it around to 5x minus 4x? Is it commutative? Is it commutative? Well, if I have 4 of something and I take 5 away, I'm technically 1 in the whole. I have negative 1x. Whereas if I have 5 of something and I take 4 away, I still have, oh, sorry, I don't know why that bounced like that. I still have 1x here. So is it commutative? No. Subtraction is not commutative. So to be able to change the order, I need to change my subtractions to addition. And I've been stressing this all year, and it is such an important skill. Whenever you see a subtraction, think of it as an add the opposite. So what can be done to allow that order to change? Oh, rewrite it as adding the opposite. Okay. Because like if I look in this case, okay, first of all, these first two, order of operations tell me I have to do this addition first. But these are not like terms. This is an x to the second y, and this is an xy to the second. These first two are not like terms. But these two are. But I can't reorder them because there's a subtraction. So what we're going to do in my very first step is I'm going to just rewrite this as a plus a negative 6x to the second y. So now these are all additions. So since they're additions, I can rewrite them. So I'm actually going to walk through the process on why adding like terms works. Okay, so the first thing I did in this first step is rewrote the addition. So we rewrite the subtraction as an addition. I'm going to kind of list the steps on why. So here we rewrote the subtraction as an addition. Now I'm going to go ahead and I'm going to reorder. I'm going to flip these two around. Okay, that is the commutative property. So my next step, I would have 3x to the second y plus a negative 6x to the second y plus 4xy to the second. So my reason for that is this is the commutative property. Basically what I did is I got my like terms to be next to each other. Now order of operations, so now I can add these two. Okay, and really what's happening when you add like terms is when you're adding like terms, really what you're doing is using the distributive property backwards. Both of these have an x to the second y. So I can rewrite it as x to the second y times 3 plus a negative 6. Because if I distribute this in, I will get back to this. Plus, and then here's my last bit that's not like, that's just kind of following along. So basically in this step, I'm using the distributive property backwards. So this is a distributive property. I'm just doing it the opposite way. I'm unmultiplying it instead of multiplying it in. But now inside here, if I do order of operations and do parentheses first, I would be adding a 3 plus negative 6, which 3 plus negative 6 is negative 3, times x to the second y, plus 4xy to the second. And then, well, when I multiply this guy out, normally we do the number first, that coefficient first, negative 3, x to the second y, plus 4xy to the second. Okay, so I'm just adding those like terms and getting to that. So whenever you're adding like terms, you're really going through this process right here. We just tend to skip Oh, what happened? Oh, sorry, I was on the wrong thing. You're really going through this process right here, except we just tend to skip those steps. But that's really what's happening is whenever you add like terms, you're using the distributive property. You're just using it backwards. Okay. So on this next part, we want to write two differences for each pair of like terms. The reason we need two is because me subtracting them is I can always do it in two different orders. So first, let's look at this first one. We have 7y. Do I have any other terms with just a y? Nope. Nope. Ooh, that one. That's a 2y. So I can either write this as 7y minus 2y, or I can write it as 2y minus 7y. So there's my two differences using those y's. Could subtract it either way. Okay. All right, what about x squared y's? Nope, that one's not. That one is. There's my x squared y. So these two. So I can either write it as negative 5x squared y minus 3x squared y, or 3x squared y minus a negative 5x squared y. So just putting those two together. And then the last one, 7, that's xy to the third. This one is xy to the third. I'm going to rewrite it. I'm just going to flip-flop my x, y to the third. So those two are together. So 72, xy to the third minus 72, xy to the third. Or if I flip it around, 72 minus 72. Wait a second. Those are the same thing. It says simplify each difference you wrote for part B. Were there any pairs of like terms for which the result was the same for both differences? Explain. So we want to simplify each of these. Okay, so let's go ahead and let's do the blue first. So I had 7y plus, I'm going to rewrite them as plus a negative 2y. 7 and a negative 2 is 5y. Okay, and 2y plus a negative 7y gets me negative 5y. So those get me a different thing. Next, let's do the green. Negative 5x to the second y plus a negative 3x to the second y gives me negative 8x to the second y. 3x to the second y plus the opposite of negative is positive, 5x to the second y gets me positive 8x to the second y. Again, those weren't the same either. Now the next one, if I have 72xy to the third plus a negative 72xy to the third, that gives me 0. And this other one is also 0 because they're the same. So were there any pairs where it didn't matter the order? Yeah, when they were the exact same thing. So yes, explain. They were the same thing. They are the same thing. So 0. When you subtract them, you get 0. And that's the only time that will work with a subtraction.